have in our hand is the two types of schedulers. So if you look at the schedulers, there are two types. Okay, two types, and for those two types, we write those two types as in this way. You are going to have first type of consideration is job scheduler, uh, and the second type is called as CPU scheduler. Okay, so this is going to be your, you can say this is long term, and this is going to be a short term. So in case of these two schedulers, what is important is the algorithms that you are going to use. Algorithms that you are going to use for this scheduling purpose. Long-term scheduler as well as short-term schedulers. Okay. So certainly, if you are using algorithm, there are certain scheduling criteria. So what are those criteria? See, we need to keep our processor busy so that maximum utilization can be there. So our first criteria for these algorithms will be, these schedulers will be the CPU utilization. So percentage of CPU utilization is very important. Percentage of CPU utilization. So we want that we need to keep our CPU busy as possible. So we want this utilization should be maximum. This should be maximum. Okay, and for utilizing this particular CPU at the maximum level, we will incorporate this mechanism into algorithms. We want the output, that is throughput means nothing but the output from the utilization is maximum. So we want maximum throughput. So means what, number of processes that complete their execution per unit of time. So certainly, if we make processor busy, we will ask processor to handle multiple processes at an instance of time. Okay, so throughput will be maximum if processor handles multiple processes, and out of that multiple processes have complete their work within the execution time. Okay, so we want this also to the maximum. So throughput and CPU utilizations are important. Now turnaround time is nothing but, see, with every process, what are important point, right? Let us try to have with every process. See, if you have a process pre, if you have a process P, then if we think about its execution, then there are certain important points that are that you need to consider. So as what we know that we know that the system has to work into certain state. So out of that state, one state is called as hold, the next state is called as ready. Then from ready we are going to shift up to run. From run, if there is any request, we are going to come here. This is called as wait. Right, from wait again we are coming back to ready. If there is no IO, then it is something like that, the process is going to shift into ready and run. So, and once it is being complete, then finish its just task, then it is going to be complete. Okay, so whenever user submit the task and it comes to a hold state where your job scheduler is exist, job schedulers exist. Here what is going to happen, a queue is being maintained, queue is maintained, and the process is being created. So job scheduler creates process for process scheduler. Okay, now here the important thing is, who is process scheduler? Your CPU scheduler, means your short-term scheduler is there. So your long-term scheduler creates a process for your short-term processor, that is CPU scheduler. Okay, so whenever we think that whenever we say that a queue is being maintained, so means what? Means what? Whenever the whenever the job is being submitted by an user, every job has first arrival time. Arrival time. Every job has arrival time. Arrival time means what? The time when the job is being entered into a system. So that has an arrival time. Now, next, with every process, you have second important thing, that that this particular process is going to consume the resources for a period of time. Okay, so for example, uh, we said that this process needs CPU for say 8 millisecond, 8 8 millisecond of time. So this is going to be considered as burst time, or in short, you can take it as a runtime. Okay, the time, this runtime is nothing but the time taken by a process is to execute its segment of code, just to execute its segment of code. This is the time taken by the process to execute its segment of code. Okay, so this is burst time is there. So this is really very important. Every process has arrival time. Now next is like, okay, say for example this process has arrived at say 10.00, requires 8 millisecond of time, that is burst time, but this has to be shifted from this hold to ready. Okay, and from ready to run it will execute for 8 millisecond of time, including like whatever IO requests that are there that are required. So it will execute it for 8 millisecond of time. So but it is not a case that this is the only process that is with the CPU. CPU may be dealing with some of the other processes also. So in this case, if the CPU is busy in handling some other request, in this case, though this is arrived at 10.00, but has to wait for some time. Why it is? Because it may be a case that CPU might be busy with the other processes also. So it has arrival time, it has a burst time, it has a certain wait time also. Okay, maybe with the respective, with every process, you have a different wait time. Okay, but every process has to wait time, or otherwise, if the CPU is free and there is no task with the CPU and you can allocate the CPU, you can do that for the instance of time. So every process has a wait time also. Okay, if wait time is zero means the time it is being arrived, the CPU is being served. So wait time for those processes would be zero. Okay, so the arrival time, burst time, wait time. Okay, so if this has say for example it is arrived at 10.00 and waited for say 8 millisecond of time. So means what, like then that process has a different start time. Okay, so with this next parameter will be start time. Okay, now what exactly the start time means? Start time means what? The time portion at which the process start executed other than the arrival time. Okay, means at this particular start time, the processor start executing the process. So that is the start time. Then ultimately you have got a finish time also. Like finish time is nothing but the time at which the process finished its segment of code. Okay, so once you know the start time, once you know the finish time, you have certain wait time, you can compute the turnaround time. So here this turnaround time comes into a picture. Now what exactly turnaround time means? Turnaround time is nothing but the amount of time to execute a particular process, including like say what is the start time, what is the finish time, and what is wait time. So usually, if your system is dealing with say n number of processes, then with every process you are going to calculate the turnaround time. Okay, so for all processes, you need to calculate average turnaround time. So for all processes, you need to calculate average turnaround time. If you say that T is the turnaround time, then if the T is turnaround time, then you need to sum all those T's for I is equals to 0 to I is equals to n, where I is nothing but the process sum of Ti, then divided by n. So this is nothing but average turnaround time. So this is average turnaround time. So this is important point. This is average turnaround time. So this is the amount of time to execute a particular process, that is turnaround time. Okay, and if you wish to calculate the turnaround time, it is turnaround time is nothing but uh, finish time, finish time minus start time. Like start time, like finish time. Let's say if it is say it is finished at say 10 millisecond of time, 10 at 10.10, and it started at 10.01. All right, so you can easily compute the turnaround time, right? So that is amount of time taken by a process to complete its segment of code. That is turnaround. Okay, waiting time I have already discussed. Waiting time is nothing but the amount of time the process has been into a waiting in a ready queue. Ready queue, where the ready queue is being held. Say this is hold queue, right? Hold queue, ready queue is being maintained. So what is ready queue here? The ready queue is nothing but the queue of the processes that are being handled by CPU scheduler. This is a queue of the processes handled by your CPU scheduler. This is important. Okay. The response time. Response time is nothing but the time, amount of time taken by a process, amount of time that is taken by a process or a request till the first response is being produced. Okay, so like it is being arrived at 10.00 and it is being responded at say 10.9. So that response time is being calculated. Okay, so this is response time. This particular response time is computed when you are dealing with the time sharing environment, right? So means like if you have a process P which is arrived at say 10.00, right, and responded at 10.09. Say for example, if this is the case, so this is going to be a response time. So you can call it as a response time. So at 10.09 it is being responded. Okay, so so this is the case. So this is going to be a arrival time. This is going to be a response time. At this particular time it is being responded. So response time minus arrival time is going to be your wait time. So this is important. So your WT wait time is nothing but RT minus AT. So so this is going to be important. Okay, so this is what you need to understand. So these are the criteria which you need to understand. So in order to utilize the process maximum, you need to have a processor at maximum. You need to set a criteria, and based on these particular criteria only, the performance of the system is being identified. Based on this criteria, uh, performance of the system is identified. Okay, so this is playing an important role. Okay, now as far as scheduling is concerned, whenever we are doing this, what we need to do is that we need to decide a policy. We need to decide the policy. What is that policy? Policy is like say, first, first we need to keep keep the track and status of the process. Okay, we need to keep the track and the status of the processor. Track and the status of the processor. Second important thing is design policy. Design policy for allocation of processor. Okay. Third is allocation of processor, and fourth is deallocation of processor. Okay, so whenever we are keeping the track and the status of the processors, this track and status would be like whether the processor is available or occupied. Okay, processor is available or occupied. If it is available, you can execute, you can take that processor. If it is occupied, then you need to wait. Okay, design the policy for the allocation of processor. Then here, the important point is you need to consider the environment. First parameter is environment you need to consider. Second parameter is parameter is scheduling criteria. Okay, so while designing the policy, you need to consider the environment and scheduling criteria. Scheduling criteria. Okay, so scheduling criteria. So this is what is exactly the scheduling criteria which we are looking forward. Okay. Now, if you look at the environment, then this environment, as we have discussed, memory management, right? There are two environments. One is first environment is non-multi-program, multi-program, and second is multi-program. Okay, whenever you are thinking of non-multi-program, there is one-to-one correspondence. And whenever you are thinking of multi-program, it is time sharing. So this is going to be called as non-preemptive. And this is called as preemptive. This you have to consider. This is non-preemptive and preemptive environment. Okay, so this is going to be there. So whenever you are trying to design policy, the consideration factors are the environment and the scheduling criteria. And based on this particular environment, your algorithm behavior is being defined. So based on this environment only, what is going to happen? The algorithm's behavior is being decided. Is decided, or you can say determined. So this is going to be an important algorithm behavior is being determined by using this. Okay, so allocation of processor, deallocation of the processor, these are going to be done. Okay, so so whenever we are going for the deciding an algorithm, so the optimization criteria will be we need maximum CPU utilization now. Okay, so the scheduling criteria was CPU utilization, but expected is maximum CPU utilization, maximum output, minimum turnaround time, minimum waiting time, and minimum response time. So these three should be minimum. So we need to decide algorithm in such a way that this turnaround time should be minimum, waiting time should be minimum, and response time is also should be minimum. The maximum should be CPU utilization and the output. So we want maximum output in minimum effort. So that is what is the best design policy which we are going to